Welcome everybody to this Innovation Lab webinar series. This is the third webinar in the series so far, and we're featuring innovation projects from across the community energy sector. So the series showcases a mixture of projects, some from the wider community energy sector, and many of them are projects that are being developed with support from the Power to Change funded programme Next Generation, which we run here at the Centre for Sustainable Energy. So today I'm really happy to be introducing Toby from Crew Energy, and this is a community group based in London, and they're going to be speaking about their Next Generation funded heat pump project. Before I hand over to Toby though, I'm going to do a really quick run through of Zoom for anyone who's not familiar. Could just have the next slide please, Toby, thank you. So the microphone and the camera functions are at the bottom. It would be great if you could keep both of these off, because it just helps to keep our sound quality clear. And also just a reminder that the webinar is being recorded and it will be shared online afterwards. So if you do have your camera on or you do speak on the webinar, please be aware that that is being recorded and it will be shared. Across the bottom, you can also see there's a chat box, and this is the best way to submit any questions. We've got Amy and Guy, both from Crew Energy, ready to take your questions in that chat box whilst Toby's speaking. And any of the more in-depth questions will be collated by Megan from CSE, and she will use those to run the Q&A session at the end of the webinar. And we'll try and get through as many of those questions as possible. You can also see from the chat box that you can select one person to message. You don't have to message everybody, but please only do this if you're having technical difficulties. You can select Megan and tell her what's happening. You can't hear us or you can't see something, and she'll try and help you out with that one. But generally, if you're asking a question, please make sure you've got everyone selected. Everyone would like to see the answers, and that would be great. There's also the participant list, which you can click on participants. You'll see the list of everybody on the webinar. You can right click against your name and press rename and change your name if it's coming up with somebody else's name or if it's just not very clear. And if you could have your name and possibly even your company or organization, that would be great. And then that helps us to see who's asking the questions for the Q&A session. There's also the raise hand function in the chat box. So if you're not able to type your question into the chat box, you can press that raise hand, and Megan will choose you in the Q&A session and unmute your microphone so you can ask a question. So that's all the sort of basic Zoom functions. Hopefully everyone can see Toby's screen nice and big in the middle. If you can't, there's sort of different views you can click through at the top of your screen where it says speaker view. Hopefully you can see that clearly. So next slide, please. So back to today's webinar. We're really grateful to be joined by Toby Costin at Crew Energy. He's going to tell us all about their Next Generation funded project to install heat pumps in London. Then we're going to run through some standard interview questions that I'll be running through with Toby. And then we'll move on to the Q&A session, which is your questions. And Toby, Amy and Guy will all be chipping in and helping to answer those. So without further ado, I'll pass over to Toby.
Morning, everybody. Thanks for showing up. Got about 10 slides here we're going to run through. And I'm going to start with a little bit of who we are. So Crew is a South West London Community Benefit Society. We started trading in 2017. Being London-based, we don't go and build 5 megawatt solar farms at the start. We're typically looking at energy efficiency. So I think our first project was LED lighting project. We've done building management systems, heat transfer solutions, and actually eventually we got around to doing some solar PV and storage in our 5th or 6th project, I think. So it's taken us a while to go the traditional route of solar PV first. And in those installations, we've typically focused on working with local charities for those installs, and funding has generally been grant funded. So either local councils, S106 money, or things like UK Power Networks. We've tapped into a couple of their grants over the last 2 or 3 years. So that's been the model to date. We haven't really gone to the community ownership so far, but this is what the funding for Next Gen will allow us to do. We also run a number of energy cafes and other outreach programs like games events for kids in schools and libraries, And we're also starting to roll that concept out to adults. So we're going to be doing some work with Richmond Council at some stage post-COVID, where we'll play some games with them to get their staff engaged in thinking about climate change and how they can actually change their own lives as well as change those of the borough. So what's our big idea? I think it was about March we were February, March we were awarded funding from the Next Gen Fund. It was 98,000 to deliver next generation of community energy models, and ours was around heat. So we're looking at renewable heat, so typically heat pumps. Being in London, it's more likely to be air source and ground source. And we targeted 3 areas that we wanted to develop markets in there. So one is civic centres, but that could also be commercial buildings. But phase 1 of larger buildings is going to be civic centres. And we'll talk about our first project as an example in these slides. We're also looking at communal heating, so a heat pump into a block of flats and how that might work. And then the domestic market. And we're breaking the domestic market down into a couple of areas. One is the able to pay market. So how do we reach those people and think about what they might need, and again, there's slides on this and how we're going to approach that market, the products that might work, the products that might not work, and the sort of pricing areas that we need to consider to make that work. Really, sorry, I just forgot to put my phone on silent. And then something that's come up more recently is the vulnerable. So we're looking at the Green Homes Grant and what impact that might have, and sort of £10,000 potentially available for vulnerable people in the community who can tap into Green Homes Grant. So that will be another area that we're looking at to develop as well. And part of our funding, we've also been awarded money to develop energy assessors. So a couple of people have been trained up to be domestic energy assessors. And they're now doing their retrofit assessment courses, and one's been trained to be a non-domestic energy assessor. And we think that there's probably work to do there, using that as a marketing tool into being able to offer people heat pumps. So when we go in, we're not just doing a normal £50 EPC assessment, we'll be doing a whole house assessment, analysing the home for renewable heat, analyse it for solar PV and other energy efficiency measures, and come up with maybe a 6-8 page report at the end of it where people can really think about how they can make their homes more sustainable. So that's the idea. So why renewable heat? I think we were looking at a few things really. There was clearly the councils were starting to declare climate emergencies. We sit in South West London, as I said, so really focused on Wandsworth and Merton councils, and they both declared sort of middle of last year, and we were part of Merton Council's Climate Emergency Working Group, where we've helped develop their plan for the next 10 years. And it came pretty clear when we started speaking to them that they thought that renewable heat had to be a huge part of what they had to deliver to hit their targets. So on their own buildings, that was going to be the case. And with Merton, that's mainly commercial buildings. They don't really own their own housing stock. But it still means there's quite a lot that we could potentially do hand in hand with the council. Obviously, there's an RHI at the moment, and that's going to run domestically until 2022 and commercially until next year, which has just been extended a little bit further. So, and it is relatively generous. You know, it doesn't cover the whole cost of the heat pump, but it certainly makes it worth thinking about compared with putting a new gas boiler in. So we thought that was a good angle. Our own mission statement is really around reducing carbon in South West London and alleviating fuel poverty. And we think heat pumps can do both of those things. I've just put up some numbers here. So a typical gas central heating system might emit 3.5 tonnes, whereas the equivalent heat pump might be less than 1 tonne. And that is if you're on a standard tariff. If you're on a green tariff, that number is going to fall dramatically from there. The other driver for us is air quality. So living in London, you know, big issue, air quality, and it doesn't matter where you are, how wealthy the area is, even in London. You know, Putney High Street is one of, I think, the third most, until recently, the third most polluted street in the country, despite being a relatively healthy area. And we typically associate poor air quality with poorer parts of boroughs. But in this case, that's not an issue. It's actually spread across the whole borough. We have this issue. And gas boilers are the third largest polluter in London. So if we can cut those emissions then we're getting rid of particulate matter, carbon monoxide, nitrous oxide. So I think they were the reasons that we were looking at when we were thinking about renewable heat. So our first project that we're looking at is a civic centre, and it's a really fantastic place. It's a youth centre in Battersea called Devas Club. They run all sorts of events for kids, so after school clubs, they have recording studios, they've got a gym, they've got a football and basketball court on the roof, they do musical theatre and dance. I mean, it's a brilliant centre, very focused on the BAME community. They do a lot of stuff about resilience, trying to make kids who come through their system more resilient, more employable. So we really like this group, and we've worked with them so far on 2 grants. So we've already installed some LED lighting and a building management system for them. We've just won an award from Wandsworth Council to install more LED lighting, some destratifiers, secondary glazing, and heat transfer solutions. And those last 3 will really help with the heat pump. Just a few quick facts on what we're looking to do. The heat demand, based on our heat loss counts, was 198,000 kilowatt hours, which means we're going to be putting in around about 64 kilowatt hours of heat pumps. That's a 4 cascade of 16 kilowatts. The system will be run by Valent, and the reasons we're doing that are 2 or 3-fold really. One is it's a relatively new boiler. They had a big refurb of the ground floor back in 2017. So the boiler is only 3 years old because that went in at the same time. We were thinking about how we keep costs down. So running by Valent means that we don't have to upgrade all the radiators. And I just think generally just the ability to have a dual system when we're talking about lots of younger kids, if you had a power cut, for instance, you wouldn't have any heating, you'd have to close that down. So this gives them some resilience to things like power cuts. We are estimating that the air source heat pumps will heat 148 of that 198,000 kilowatt hours. So, you know, a big chunk of it. And that number is likely to rise. The building management system will allow the building to zone various sections, and therefore the heat pump will be able to cope more with heat load even at lower temperatures. We've based the calculations off of 4 degrees. So anything 4 degrees or above, the heat pump will do all the heating. And in London, you know, that is pretty much the whole time. So we think that number might creep up. We're obviously basing our calcs on a 20-year average, rolling average of heating and cooling degree days. So as we move through time, we know that's accelerating anyway. So again, that's going to support more heat from the heat pump than it is from the gas boilers. Basis that 148, we'll be looking at saving around about 26 tonnes per annum. And we're looking at probably around about 48 to 50,000 pounds is going to be the final number for the install. And we'll do that for a community share offer, which will be our first community share offer. So that's all very exciting for us, and it'll lead to a couple of others that we've got in the pipeline. And we're looking to install that in November. So share offer is going to run from, I think, the 21st of September, hopefully, to the end of October, and then we'll look to install towards the end of November. So when we were looking at this project, what were our considerations? And I won't run through this in the order it is, maybe, but I'll just talk sort of generally about it. I think the first thing for us was we had a really good working relationship with Devas Club, and I think that's important. Having already worked with somebody, they know that you can deliver, you know what their issues are, and there were always issues. Like one of the issues we faced was when we were going to do some drilling to put the building management system in, that actually we couldn't go one day because it was a polling station for the day. So we know that there's those issues, and we know how to therefore communicate with Devas now about what this will entail, how many days the installers will be there, the amount of noise and upheaval they'll be creating, and then fit that in with what we know the schedule is. If you work with somebody that you've worked with in the past, you also know how the building is used. Building ownership will be really important. And in this case, Devas own their own building. A lot of civic centres, you're dealing with somebody, but actually the council owns the building, then you've got to talk about tripartite agreements to make these things work. So Devas ticked a lot of boxes for us from that point of view. The building structure is kind of interesting because it's a bit of a 70s monolith of a thing. So big concrete slabs, which again is useful for us in terms of store, really, thermal store. So we can actually put heat into the building. It will hold in those 500 mm concrete floors for quite a while, which means that we've then got options about shifting heat and doing some interesting things around heat shifting and day-night terrace and those kind of things. So that was good. The other thing for us with Devas is they're really committed to reducing their carbon footprint and being net zero. So their current ambition is a 5% reduction per annum until they hit the net zero targets. So we're working with a partner who's thinking the same way as we are. And again, I think that on these projects, which are pretty technical and pretty difficult, it's important you've got that buy-in from the client, really. And one other thing that works quite well at Devas is that they've got this big flat roof and there's solar PV at the front of the building. There's a football court at the back of the building, and in between there's a bit of a no man's land of space. So we can actually put the heat pumps up there. They're away from local residents. They're out of sight and out of sound. So it's a pretty easy installation from that perspective. We won't get anyone to see public. Lots of things that made us go with that project. And we're now looking at 2 or 3 other buildings. So we're looking at a theatre down in Wimbledon, the Polka Theatre on Wimbledon Broadway, and whether we can make heat pumps work there. And the economics are a little bit more difficult on that particular site. And we're also looking at a Buddhist centre in Kennington as well. So we're trying to stack up a few projects behind this one, try and make the most of the RHI while it's around, and see if we can make progress on those too. So the other area we're looking at is domestic market, and London's difficult because we're limited to air source heat pumps. Ground source really aren't an option because we just don't have the space in London for ground source. So the only area we might is working with community land trusts, and we're in conversation with one community land trust at the moment, very, very early stages, but that for us is probably the only area that we feel that there might be a use for ground source in a domestic sense. Cost-wise, we've priced up a couple of jobs so far, and we're looking at sort of 13 to 15,000 pounds. And then when you order the RHI, you're kind of ending up around about 3K short, which is, I guess, roughly the cost of a gas boiler. So it kind of looks similar, right? You're going to get that money back over time. I guess the one bit you got is the time value of money on the 10 to 12K you're going to receive back. So it's not a slam dunk, but it's a good argument to have with people on why they should do it. You can more or less end up in the same place after 7 years as you would with your gas boiler, but with lower maintenance costs. You're not going to have gas safety checks and those kind of things. So you can make the case for it as it is. What we're looking at, particularly with GHG around the corner, is can we get those costs down? And one solution we've come up with is looking at a bivalent option where the heat pump might do the heating and the gas boiler provides the hot water. And because the plumbing is much more straightforward, because of not having to run the heat pump so high for the hot water, so typically a heat pump will run the hot water system at 55 degrees, but the heating system only at 50. So you're going to get better efficiencies out of the heat pump. And we're looking at costs of between 8 and 10 there. So that fits in very much with Green Homes grants. Be it the vulnerable people who could have the whole 10K and actually get a heat pump to replace their aging boiler, or for able to pay market where 5K, okay, great. Then you're adding 3 on top, which is similar to paying for a gas boiler. So we think that's kind of interesting. My colleague who's on the call will probably answer some of the technical questions today. Guy is also looking at hybrid heat pump systems. So a heat pump with a small gas boiler built into it. And again, they come out more in this sort of 10K range than the 15K range. And we're looking at that as an option as well. So we're trying to find solutions, and we're not just doing that on price points. We're looking at things like where the heat pump's going to go and noise as well. So heat pumps are considered permitted development, but you've got to be with 1 metre away from the boundary wall. So for us, that's kind of problematic in London. I measured the width of my house as a test on this, and it's 4.5 metres. So you're essentially sticking the heat pump in the middle of the house. 1 metre either side, so you've only got 2.5 to play with in the middle. So that's difficult for people. So design will become important. So what do these things look like? They're typically going to go in the back of the house rather than the front, because people probably won't want this unit sitting there at the front. And as close to the house as you can makes it cheaper. If you have to start channeling and insulating pipes, costs start to go up. So it'd be great to put them at the end of the garden, but that might increase the cost by £1,000, maybe £1,500 to do that, for instance. So, so we're looking at maybe heat pumps that just look nice. Might be an easier sell than heat pumps that might be the uber efficient, but they're kind of big grey boxes. So lots of things to consider, including noise. So we see the range, and you've got something like at the quieter end, something like an Oshner, which is a pretty expensive unit, but it's 29, 30 decibels. So incredibly quiet. That's considered whisper quiet. London background noise is 41. And a lot of the heat pumps around that 40 to 50 level. Some get up as high as 66, 70. So again, that will be an issue. And it'll be an issue increasingly as we add more and more of these heat pumps to a street, that constant humming going on. And I think people probably experience a little bit of that with EV charge points. You know, I notice here in London, walking past EV charge points, there's that constant sound. And I think we're just going to get used to that with heat pumps as well. But you can, yeah, there is a range, and it's worth looking at different heat pumps to see what will work. So domestic market, how do we tackle this market and how do we market to it? I think the obvious place to start for us is early adopters. So people have got, I've got a slight typo in this, apologies, but solar PV plus battery storage, maybe EVs, and they're thinking, what can we do next? Well, the next obvious thing is heat pumps. Let's get rid of your carbon emissions out of your gas flue. Let's improve air quality. So there's drivers there. So we need to kind of focus and target on that market sector probably first and foremost. People on time of use tariffs are probably got solar PV and battery storage as well. But again, that's an interesting space for us. We've done a bit of analysis on Octopus's Agile tariff, which is kind of the easiest one to look at the moment, really. And if you avoid 4 till 7, the average tariff price over the year is around about 8 to 9p. So with a, say, even a 300% heat pump, you could be paying 3p at 9 pence for your heat. And yeah, we're looking at heat pumps at 350 to 400% efficient. So you could be close to 2 pence if all goes well on that system. So time of use is really interesting. And then we've got to look at how we shift. So we're doing some studies on that. And I think I've got a little bit further down where we can talk about those kind of ideas and things to think about there. I mentioned, I think, in the first slide about the vulnerable component. And Green Home Grants have got us thinking about this earlier than we probably would have got to it, just because that 10,000 is available. If we can combine our hybrid solution with Green Homes, you can actually deliver this stuff for nothing. And we've recently been approached by Wandsworth Council to support their application for LAD, which is the local authorities delivery scheme, which is their version of Green Home Grants. I think it's half a billion or $1 billion is available to them. So they would like us to help them with energy assessments, getting our installers on their framework, and then maybe rolling out a program where they're focused on 2 areas really. One is vulnerable people who own their own homes that they've got a database on. And the other one is private rental sector. And I think they're looking at minimum energy efficiency standards. So they can say, right, you guys are F and Gs, you shouldn't be renting, you need to take these measures. There's funding available, take that funding, get these properties up to spec so you can start renting them again. So that's their plan. And then we're looking at things like eco-funding and warmer homes. And quite often you can combine eco and warmer homes into one grant to deliver. So potentially we could deliver a hybrid heat pump with those 2 combined. So that's how we're looking at the domestic market, and we're looking to launch that really in the next month or so. Communal heating is third on the list here because it's the one that we're doing next. So it's in this phase that we're starting to consider and try and find buildings, and our plan is to deliver in our next phase, which I think starts in November of this year and runs through for about 4 or 5 months. So we have found one building, and I'll talk about that a little bit later. But initially, if we're looking at solutions, we're seeing 3 potential solutions in London. One is shared ground array, which we think will be difficult because there's not a lot of green space, and it's much more expensive to start digging up parking bays and playgrounds than it is to dig up green spaces. So we think actually that may be difficult, though we are looking at different technologies. where people dig deeper and they use different products to capture heat, so that you might only need 6 parking bays rather than say 30 or 40 parking bays to take the same amount of heat. So there are options there, but we wonder about the cost of those. So on this first project, we're looking at potentially an air source heat pump per block or per riser. So you'd have an air source sitting at the end of the block that would feed through. The advantage for us there is clearly cost. It would be less than half the price of looking at a shared ground array. The other thing for us is if we can find communal heating systems where they've got a gas system already, replacing that is relatively easy because the internal pipework of the building is already in place. So we really only have to fix our units to the outside of the building and then start running up those risers, and then we have our solution. So we think that's interesting. And then there's a relatively new concept, which is a dual loop system. And what that means is you preheat water to around about 20 degrees outside, and then you feed that into essentially small ground source heat pumps in the building, like a Kenza shoebox, for instance, to then boost that 20 degrees up to 50 degrees to heat the flats. This dual system could either be a much reduced ground array, which will make it cheaper, obviously, or even an air source heat pump. And because you're only heating to 20 degrees, you'll have really high efficiency there. And because you're starting at 20 degrees in the flats, you'll have really high efficiency in the flats. So that efficiency might be in the flats starting at 20 degrees, 500, maybe 600%, depending on the system you're using. The other thing when we're looking at, or starting to look at communal systems, we're really thinking about building ownership, and the first project is a council-owned building, and it's split between renters and leaseholders. And the fascinating thing, it being London, is only a third are renters, the rest are leaseholders. So you really have 2 camps you're dealing with: the council and their third of it, and then the TMO and the other 2/3. So they're pretty complex projects because you're dealing lots of stakeholders, and then you've got to deal with that individual level to sell the concept to each householder as well. But things like Green Homes grants and RHI really help with selling that concept. And if we're going to community own these, then they don't have to worry about the funding. They've really just got to worry about their net running costs before and after, and we're showing them how the numbers stack up on that. Social landlords will probably have similar splits. So again, you're dealing with that. So one area we're looking at trying to focus on is small housing trusts, where they all have a share of the freehold. You might have 30 flats in a block. And there's quite a few of those in Wandsworth and Merton that we need to consider. And then finally, private landlords who might have a small block and maybe 6 flats. So for us, that's the communal heating market. Going to be a tough one, but I think it's just finding the right projects to work initially. I mean, one area to think about in terms of where the best benefit is for the residents is probably electrically heated properties. And in the UK, around about 5% of properties are electrically heated. The bulk of those will be blocks of flats, and somewhere like Wandsworth, 40% of housing are flats. So we think we will find properties particularly in the borough of Wandsworth, where the council still own the housing stock themselves, that will work on this basis. Because if you're on a storage heating system, you might be paying 12 pence per kilowatt hour, maybe 14p. So we've got a lot to play with here. If we're bringing in electricity, and particularly if we can bring it in via the council's laser contracts, where they might only be paying 12p, you could be paying 3.5 pence for your heating, which then allows us to charge additional fees to make the economics work in terms of the investment. So that for us is what we're trawling through with Wandsworth Council at the moment, seeing if they can find us the right building to run some trials on, to kind of persuade them this is a way forward. And community-owned assets are a great way for them, because they're short of cash, to deliver these heat projects and get the carbon reductions they're looking for. Just a few things to think about on communal heating. It's a commercial tariff of 20 years. So on the domestics, you get 7 years of RHI. Here you get a lower rate. So we're at, say, 7.5p on, 10.5p on RHI for domestics. Here you're getting more like just under 3p, but you get it for 20 years. The good thing about the commercial tariff for communal heating systems is it's deemed demand. So you take the EPC, you look at the space heating demand and the hot water demand, and you add those up per flat, and that's the heating demand of that building. So you do have a known return on investment. You don't worry about metering and how much the house is consuming or not consuming. So that's kind of good from an investment perspective. The other bit is you're typically going to have to charge them something else on top of the RHI. The RHI is not enough necessarily to deliver these projects on their own. So you're going to have to either look at heat metering or service charge. And service charge is better because it reduces the amount of regulation you have to deal with, and heat meters cost around £400–600 per unit. So you're avoiding that cost as well. If you look at communal systems, they're kind of interesting because actually it doesn't typically matter who uses the heat. They split it across the 20, 30, 100 flats, whatever it might be, basis the size of the flat rather than who's consuming it. So again, that falls nicely into the service charge solution than it does to the heat metering solution. Credit risk is a factor, and again, the point I've just touched on there, if you're going to face residents, you're creating a credit risk. So then you have to maybe think about prepayment smart metering rather than taking credit on those. Ideally, you want to find a solution, maybe like this communal system we're looking at, where the council are paying the gas bill and then claiming it back through rents or through the TMO. Therefore, you're not ever facing the resident directly, you're facing then much easier credit solution. And then we've got to look at economic factors that can make this work. So if you can get the council's laser tariff into that building, rather than say 12 or 13p, rather than lots of people paying 16, 17, 18, 19, even 20 odd pence on old prepayment tariffs, that's going to make the economics much better for the residents ultimately. And then things like having shared water tanks. If there is a plant run, you could have 2 big tanks rather than, say, 10 tanks in each flat. That's obviously a lot less insulation work. There's economy of scale in having bigger tanks rather than smaller tanks. And if you're sharing the hot water over 10 flats, you don't need the same amount as if you had it for 10 individual flats, because not everybody is going to need all that hot water all at exactly the same time. So we're constantly looking at how we can shave, because the economics on these projects are quite tight. So you're constantly fiddling around, looking at where there's extra income, things that you can do to make these projects work. Then finally, post-RHI landscape. And I think we've got a question coming up on, how is this going to be able to be copied by other community groups? And this slide probably, is a little bit of a nod towards that. So we know that the RHI is going in the next year or two. The government have put out a consultation paper suggesting they're going to offer £4,000, no matter what the technology, just a flat rate for domestics for £4,000. We're less clear on what it means for commercial, but that's the debate going on at the moment. There's rumours being floated that they're floating around a 6,000 number. Would that be more acceptable? Because 4,000 just not going to make people swap. If we think about those original numbers of, say, £15,000, you're going to get 4,000. You still got to find 11 yourself, whereas a gas boiler costs you 3 or 4. I mean, you're just going to keep using gas. That is not enough of an alternative. So they need to think about that and look at it. And there's rumours that it might end up being around about 6. Clearly, this scheme will encourage air source over ground source. Air source heat pumps are much cheaper to install. You're going to install a ground source for maybe £25,000, £30,000 compared with £15,000 for an air source. So if you're only getting £4,000 or £5,000, you're going to choose the cheaper solution. So that's kind of interesting. And I think it kind of makes sense. We're looking at air source heat pumps now that are 350, 375, even 400% efficient, which is pretty much matching ground source. The Kenza shoebox is only around about 310% efficient. So if we look at the communal project we're looking at, we're probably going to put in NEBI units if we do this project at 376%. They're more efficient than a ground source solution. So that kind of works. And obviously, global warming is also probably having a factor here in that we're, particularly in the big city centres, you're getting less and less frost, less and less cold overnights. So actually the air source heat pumps are going to do just fine. Clearly looking at things like hybrids in the short term until the price of these things come down. And there's 2 areas I think prices need to come down. One is the units themselves need to get cheaper, and they clearly will. Technologies all get cheaper. We've seen that with solar PV over the last 10 years. But I think also people have to get better at doing the installs. And hybrids certainly make that install easier. You're essentially just tagging on a secondary heating system to the main pipework rather than replacing the whole unit. So you could save, you know, £1,000, maybe £1,500 on the installation just from going for a simpler hybrid system than if you were going with a heat pump doing everything. So things like that. And then drive for additional income. So we've touched on this a little bit, but demand side response is potential. You know, if we could aggregate up a whole host of heat pumps, there may be income there. You know, a 16 kilowatt rated heat pump might actually therefore be considered 4 or 5 kilowatts of demand response. So you don't need too many to start having some kind of impact on the local substation. So all right, I can respond by taking energy at the moment and filling my hot water tank or my additional storage tank. Yes, I can start running to balance frequency. All those kind of things could be considered and potential income. We're working with a couple of groups on how that might work, and we'll be producing papers over the next year to kind of look at those and see what potential there. The other big area for us is heat shifting. We touched on this with the agile tariff with Octopus, and clearly if you can move heat around, and let's say you've already got solar PV system and you've got storage and you're already avoiding 4 till 7 for your general usage of TVs and everything else, if you can also shift your heat, then you can have a massive impact on your running costs. So going from maybe a 15p tariff, which I think roughly what the agile tariff is, down to that sort of 8p-ish, and then dividing that by 375%, and therefore only being 3.2 pence of heating is really, really attractive, rather than paying, say, 4 pence. So, sorry, what am I saying? 2.2 pence rather than 4 pence. So there's stuff to do there, and again, that feeds back into the economics that makes it more investable. And then you need to think about, when you're modelling this and marketing to people, if they can get off with gas completely, then they're avoiding £90 standing charge a year. So that can go into your financial model over a 7-year cycle or over a 20-year cycle for a communal heating system. Then there's gas safety checks, if it's for the private rental sector or for social landlords. Okay, that can be 100, 150 a year when you're including the service on top of that. So those bits need to be added in, and that's how we kind of get to this post-RHR landscape of making numbers work. If you got, say, £6,000, then you could save that's 250 a year from gas safety checks and the service charge. Okay, that's another couple of thousand a year with inflation over that 7-year cycle, plus the energy savings. You start to show how you can replace these gas boilers. So anyway, I think that might be it. Yeah, that's me and us on where you can find us. If you'd like to know more, please drop me an email or reach us on the website and contact info. Any questions at the end? I think we've got half an hour coming up of set questions, and then more questions thereafter. We'll do what we can. Thank you for your time.
Great, thank you very much, Toby. I can see that there are a couple of questions coming in on the chat box, which is great. If everyone can carry on adding any questions into there. And yeah, like Toby said, we're going to do sort of half an hour of set questions now, and then we'll come to your questions after that. So first question from me, where did the need for your project originate?
Odd answer, but I think Philip Hammond was probably the start of this. It seems a hell of a long while ago now, but it was only last spring that Philip Hammond was our Chancellor, and he made an announcement in the spring statement that from 2025 there would be no new gas grid connections for new builds. So that was the beginning for us to see that this government was turning around saying, we are going to be phasing out gas boilers. So that gave us some confidence. And then I think jump forward another 3 or 4 months, and we had climate emergency being declared left, right and centre, to the point where I think we're now up to, is it 70% of councils declare climate emergencies? In London, I think there's only 2 boroughs out of the 34 that still haven't declared. Wandsworth and Merton, for us very specifically, declared, I think, in the summer and summer of last year, and maybe September was Wandsworth. So we knew at that point there would be interest from the councils on this. we were then invited by Merton Council to be part of their climate emergency working team, I think in August of last year, and that started in September. And my initial conversations with the eco team there, when I chatted to them, was very much around, well, we're going to have to get rid of all our gas boilers to make this work in the next 10 years on our own stock, and then really think about how we can encourage the rest of the borough. And for them, because they don't own their own housing stock, they're only 2 or 3%, I think, of total emissions from buildings. But it was a good place to start. So for us, we felt that we might get support from the councils to work with us on a community solution. I end up heading up the buildings and energy focus on that project. And that whole project, including green spaces and behavioural change and transport and everything else, has been passed by the council now. And the next stage is how they're going to implement, and the current proposal is to implement that by supporting community engagement and community projects, which is great. So that was probably part of it for us. I think lack of alternative at the moment. I know people are talking up hydrogen, but we know the economics aren't quite there, particularly when you look at green hydrogen at the moment. So for the next 2, 3, 4 years, there's a clear run for heat pumps to really be the only solution that is going to work economically and viably. Yeah, and I think that was probably it, really, Rachel. I think they were the things that we thought about, and probably air quality. I think the air quality was the other one. We started doing some research on that, and just how much we pump out of particulate matter, carbon monoxide, nitrous oxide in city centres, and thought, well, there's another area that this has a massive impact on.
Yeah, definitely. So I guess the need was always there, especially in London, to improve air quality, but the fact that national policy was finally starting to look supportive sort of gave Crew the confidence to go ahead with these kind of projects.
Yeah, and I think the other thing in being in London is we're generally at a disadvantage to the sort of the groups further out, like if you're Brighton or Bristol or wherever, where they've been really successful, because they're very close to green spaces, and we're not. So we need to do lots of little projects, and actually heat pumps kind of fit very well in that. You can do lots of domestic houses, or you can do lots of small industrial sites, or lots of little factories, because we have lots of those things in London. So we're kind of an advantage in this area, say, because there's just so many little businesses. So I think Merton has, for instance, 15,000 businesses. It has 85,000 domestic homes. Wandsworth has 145,000 domestic homes, and it has something like 40,000 businesses. So these two boroughs, which are probably about 500,000 people, have a lot of target for us.
Mm-hmm. So it's about finding the right opportunities for the right places. Absolutely,
and the right products, as I mentioned in the presentation. We need to find things that people won't mind having outside their homes, really.
Yeah. Okay, great. So next question: who are your key partners?
Right. Yeah. Installers. We spent a lot of time sort of just before lockdown speaking to lots of. Well, I say lots. When you kind of Google heat pump installers London, not many come up. Came up with about eight or nine actually. We also looked at the lead generation companies, so Renewable Energy Hub and Green Energy Hub. One of them had none. The other one had 6. When we looked at the 6, only 2 of them were MCS accredited. So the other 4 aren't really heat pump installers at all. So we started interviewing people, having chats, just seeing their general enthusiasm to work with community energy. And actually of those, only around about 3 we felt were really professional, kind of knew what they were doing and seemed eager enough to actually work with us. So that was our starting point, really. The councils clearly are going to be absolutely key to our success, or the speed of our success. I think we can be successful because lots of people need heat pumps. But how quickly that happens will depend on, and in a few ways, it's not just the council giving us projects like, I don't know, all the libraries in Merton or something, or housing stock in Wandsworth. It's also about them helping us on the outreach. So clearly they want lots of people to have solar PV, heat pumps, put LED lights in, have smart heating systems. And they're probably going to end up using groups like Crew and other groups across the country for that outreach. So it's how quickly they get to that point and how much support they give us in terms of marketing will be key. And then I think for us, it's really working with things like local civic centres. So, we've got a really good relationship with Devas Club, and this will be our third project. We've got a really nice relationship with the Polka Theatre, and it's just slowly but surely building those. And sometimes you don't build those directly. You build those via somebody else. So actually the polka came from the local bid group in Wimbledon, which is called Love Wimbledon. So actually by working with bids, we get to fan out across the boroughs. We're working really closely at the moment with Wandsworth Chamber of Commerce. And they would like us to do a gold, silver and bronze award for businesses. So businesses come in, be audited, say, look, this is where you are. If you added these additional measures, you could get to a gold standard. And then just see if the sort of the ego element or the completely green credentials element really kicks in for people, and they take those extra measures. So I think finding groups like that to work with and get support of. And again, we're kind of lucky in London that we've got lots of hubs. So there's a Putney bid, there's a Clapham Junction bid, there is, I think, a Morden bid. So we've got lots of groups that we can speak to and reach out to and therefore filter. The other area that we found reasonable support from is some of the local MPs, particularly in Wandsworth. So working with them, they then introduce you to local charities, local civic centres, and that's kind of helped us. The other area that's helped us is actually running our energy cafes. So we start by having energy cafes at civic buildings of some kind or other. Could be like local estates have their local, have their little venue, and then we start talking to the guys who run that and say, well, we could do a community fundraise for you to make this building more sustainable. So lots of different avenues really, but the main thing is just talk to as many people as possible, I would advise.
Okay, great. So the next two questions are about impact. So what sort of social impact do you aim to have, or are you already having?
So there's a few, well, I mean, we haven't launched our fundraise yet, but there are obviously lots of impacts. One is resilience of the site you're working with. So first up, Devas Club for us will be reducing their bills, will be decreasing their carbon footprint. We'll also be improving local air quality because their gas boilers won't be pumping out 100% of the time. They'll only probably be pumping out maybe 85, 90% of the time. So that's key. We're always trying to build into our funding models some funding coming back into us to help us run our energy cafes, our eco games. So for instance, at Devas, we've already run a eco action games event where the kids play giant snakes and ladders, higher and lower, those kind of things. We will run energy cafes because Devas hosts inclusion lunches on a Friday. And at some stage, we're planning to have a big event where they have the movie The Age of Stupid. They're going to show that. And then we're going to have seminars talking about the various technologies and what people could afford to do themselves, or how they could hitch up with grant schemes to make these things happen in their own homes. So I think on the social side, all those things are really important. And obviously, getting into schools and talking to schools about how heat pumps work and then installing them, we could then actually maybe outreach to the parents and talk to the parents about how their heat pump is working at school and how they could have one in their own homes and therefore function that way. So I think social impact wise, that's how it works.
Great. And what about the environmental impact that you're already having and hope to have?
Yeah, so air quality, as we've mentioned, massive impact there. And obviously, carbon-wise, if you take a domestic home, that 3.5 tonnes against 0.95 tonnes that we put on, I think, slide 2, is a really good case in point of what it can do. If you married it up with a green tariff, that could be down to say 0.25 of a tonne of carbon. So huge percentage-wise reductions in what you're doing. So yeah, they're the obvious two areas where we're having an environmental impact.
Great. So what is the potential for your project to be replicated by other groups in different areas of the country? And if someone were to replicate your project, what do they need to consider first?
Yeah, so I think part of the reason I put the post-RHI slide in was in reference to this question. So we are trying to build resilient models, so models that will work post-RHI. And obviously there's unknowns there, right? We don't know if it's going to be £4,000 or it's going to be £6,000 or what it's going to, you know, how it will work for commercial, or whether it is only going to be £6,000 or £4,000 for commercial sites as well. So we're constantly trying to produce papers on each step. We're posting those on Basecamp. If anyone wants what we're posting, we will start maybe putting those on social media. So if you follow us on social media, we'll send out links going forward of each post that we are, each presentation that we're doing. We'll send you a link where you can download those. So today, I think we've done stuff on heat metering. So looking at the heat meter market and who we feel might be good people to partner with and why, and the products that are out there. We've done an initial paper on demand side response and the potential for it. We will definitely be doing more work on heat shifting and what that could look like in this phase. So we'll be sharing that. We're really keen to partner with people on projects. So if we look at the communal heating system in Islington, that's come out of our relationship with Power Up North London, so another London community group. They were already in conversations with a couple of sites up there about solar PV, and they kind of picked up on the stuff that we were doing. I think we gave a small talk at Community Energy London about this project, the Next Gen project, and that kind of triggered interest from 2 or 3 groups, and Power Up North London were the first ones to come to us, said, could we partner? And we were looking for sites anyway, so it's great. So we think through those partnerships, we can help other groups get up the curve and actually do their own projects. And then I think it really is just working with CSE, working with CE, working with CEL, Community Energy London, Community Energy England, maybe Renew Wales, doing presentations, Community Energy Scotland, doing presentations at those venues, or making information available to them so they can pick up on the information that we're producing and just learn from our successes and learn from our errors, really, because we're bound to make some along the way. So I think it's just that constant reporting. And I think that one of the great things about Next Gen is there was a huge amount of what's the right word? Influence from CSE to say, look, we really need you guys to be kind of producing reports. So phase 5 of our project, the final phase, is writing up what were the good points and bad points of the legal, what were the good points and bad points of our marketing campaigns, what was the good points and bad points of our installation, can't remember, we got 5 or 6 or 7 different areas that we are going to be writing reports on that hopefully the CSA will then share with the wider community or via social media, via their website. So yeah, I think it's that. I think it's just being as open as we can. If anyone wants our models, more than welcome to have them. We're happy to share everything that we're doing as we go along. Just drop us an email, really, or catch us on social media. But again, as I say, sign up to our social media, careerenergy.ldn, and we will start, as we produce something, we're published on there anyway, so you will pick it up naturally.
Great, yeah, and CSE will definitely be sharing all the great resources that you're creating, probably on the Next Generation website whenever they're sort of ready to go. So yeah, anyone who wants those resources, keep an eye out on there, or get in touch directly with me or Toby. I'm sure we can share some really useful stuff. So last question from me before we go to the Q&A session. What are the key lessons learned that you think other people should know?
I'd say this is very early stages because we haven't done some installs yet and we haven't faced those issues. But so I've got a short list, but I'm sure this list will grow over time, and we will share this as well. But I'd say first thing up is ask for help. There is a lot of skills within the 2 Next Gen groups, phase 1 and phase 2. So the people like Green Fox, for instance, have already done heat projects. So have a chat with people. I think Bath and West are looking at kind of heat shifting. So if this wasn't COVID, the CSE would have made sure we would have had lots of more face-to-face meetings and spent time where you have a 20-minute breakout and you start having a chat about these things. It's a little harder, and we all feel a bit more remote at the moment, but yeah, we need to probably work a little harder on having Zoom calls like this, where we sit down, we have breakout rooms where the people involved in heat projects, for instance, all sit down and say, right, how are you solving these issues? So I think asking for help and everyone, you know, it's a brilliant industry, I think, community energy. People are always keen to share their knowledge and eager to support. We found really nice support on our fundraising, for instance, from the likes of Power Up North London, N10 Energy, Celsea, Besco, Repowering. You know, they've all shared, you know, their literature with us, made it much easier to write our own. They gave us tips on how to market our share offers. And there's just so much help out there, and people have the time for you. So just ask, and certainly ask us. We're really, really keen on this stuff. I'd say speak to lots of installers. That really helps. You get a feel of what's going on, but you also get in the loop. You know, if you're not in the loop, you won't know that last week there was an MCS presentation on what they had found out from the government on the Green Homes Grant. So I went on to that, but it was only because one of our installers, Green Square, said, hey, this is happening tomorrow. Do you want to be on it? Yes, please. Great. He got me on it. So those conversations, I think, are really important. Trying to find people who are technical specialists are really, really key. We're really gifted to have Guy Thompson on our team, a brilliant heat engineer. And again, you know, because he's in that community, he's forever sending us brilliant papers. We got a fantastic consultation paper write-up for the government's white consultation paper on what's next after RHI, which really helps us write our own consultation back to the government. So having those kind of people on board, brilliant. Those kind of guys called Guy, really, really helpful. Yeah, I think one of the other things we're learning very quickly working with Devas is it's great that they're on the same page as us. You know, they want to reduce carbon. That is their starting point of this conversation. Whereas lots of people, it's okay, can I save money and can I save carbon? Yeah, we can, but you know, if the project's they're marginal, they might say, yeah, I don't know if I want that risk. Whereas with Devas, they're saying, well, you know, we want to do this. So I think that really, really helps. I think finding people who understand their own building really, really helps. So the fact that a third of the Devas building was refurbed in 2017 meant that the team were really kind of up to date on how the boiler works, what it feeds. They can answer questions. Whereas you go to a building that hasn't been touched in 40 or 50 years, everyone goes, well, I don't know. I don't know where that pipe runs to. I don't know whether the boiler feeds this or that, or much, much harder. So I think they're things to consider, and certainly lessons learned for us is take the easiest path on your first project. You know, if something feels really challenging, maybe say, okay, we're going to come back to you on this at a later stage. We've got another project we need to go with first. Work out how to do the easy project, then you can do a slightly harder project second time around. I'm just looking at my notes here. In cities, yeah, so this thing in cities, we need to find the right solution. So start with with what might be the right solution first. I think don't go and find the right building first. Think about solutions that will fit a typical building in your area. So we talked a lot on the domestic solution. It's pointless us marketing a huge, great, say, 1 meter square box that's grey and ugly and bangs out 70 decibels as a solution for a nice domestic home, because there's no way I'm having that outside my house. So spend some time before you start marketing products, knowing what that ultimate solution is probably going to be that is most likely to sell, I would say. So I think there are lessons learned so far. There's some real technical stuff we've learned, but probably, you know, not for this audience right now, but just very brief capture of those. Things like thinking about getting heat loss calcs done early to understand what the heat demand is going to be, rather than just looking at energy bills, because energy bills might not tell you everything. Devas might be a case in point. You know, they consume 168,000 kilowatt hours of gas. I would only know the fact that they need a lot more heat than that because I spent a lot of time in a building, but come the winter, you will see loads of little plug-in radiators on the top floor of the offices because there's not enough heat there. So knowing those little bits are really important. So having heat loss counts up front and getting those paid for, and they're not cheap. You know, I think our heat loss counts in Devas were £1,000. So having to sort of pre-fund that kind of stuff is kind of important. And then there's lots of little bits and pieces that can get quite technical when you're looking at hybrid solutions against a split hybrid solution, for instance, hot water being done by the gas boiler against being done by the heat pump, and what the pipework looks like for that. Those kind of things will come up, and we're learning stuff the whole time, but really technical little bits that we can talk about maybe in a smaller group if people want to get into those.
Definitely. Well, thank you very much, Toby. That was really, really interesting. And yeah, definitely on the sort of facilitating introduction side of things, Centre for Sustainable Energy and Community Energy England are always really happy to introduce people. And, you know, if you want to speak to someone about heat pumps or electric vehicles, definitely get in touch. We always know someone we can put you in touch with for those good conversations. And yeah, as Emma was saying in the chat, Community Energy England are working on their website a lot at the moment and have those sort of member areas to connect with each other. So please keep an eye on both our websites. And also just let us know if there's things that you want, if there's a forum that would be useful. We're always up for hearing what would be good for everyone. So yeah, let us know. Great, now I'm going to hand over to Megan for our Q&A session. I can see lots of questions coming up in the chat, so I'll hand over to you now, Megan.
Okay, thank you. And thank you to everyone who asked your questions. I will take it from the top. I can see that some of them were answered by yourselves in the chat box, which was really great. So thank you to those who posted links and things like that. So I got a question from Will. It says, question for Toby, are Crew actually investing in the domestic heat pump installations via share offers?
No, we're not. No, that really is able to pay and potentially things like GHG. So our share offers will be around communal heating systems and commercial. So something that's got a bit of scale to it that's worth raising for. I think the credit issue on doing lots of individual houses is a difficult one to look at up front. So I think for now we're really looking at the eco warrior types and where we can get, say, £10,000 of GHG funding for vulnerable people will be our starting point. Ultimately, I think it's an interesting area to get to, that sort of finance solution. And we can look at finance solutions via social funders like Parity Partners and people like that who are interested in investing in this space. But for now, you know, that's a bit more of a credit trade than it is a heat trade for us, and we're not credit people.
Okay, thank you. And we've got a couple of questions around kind of community buy-in. A question from Tracy saying that she's received feedback that communities that they don't want to buy into ecosystems because they're too expensive and they can't afford to change over to eco-friendly systems such as solar panels and heat pumps. How do we overcome this issue to reduce carbon footprints?
I think we look at some of the points I've made in the presentation. If we're talking very much domestically there, for instance, if that's the point she's pushing there, is hybrid systems. You know, so here there's a scenario where we could potentially have £5,000 of Green Homes grant up front. Let's say the heat pump might cost £8,000 for a smallish 8 kilowatt heat pump installed as a hybrid system. You will probably then get £3,000 or £4,000 back of RHI over the next 7 years on top of that. And just be clear, I didn't mention this in the presentation, the Green Home grants is not additive to the RHI. If you were going to get, say, £12,000 over, which is pretty much the maximum getting an air source, over 7 years, you only get £5,000 up front, Green Homes grant, plus £7,000 there afterwards. They claw back each year a bit of that £5,000. So it's kind of looking at things that will make that work on the economics. The other thing there to consider, Megan, is the stacking of other numbers. So saying, right, £90 per annum over the next 7 years is 630, but actually it's more because of because of inflation. So let's call it £700. So £700 you will save by not having to pay for a gas standing charge, assuming that you get rid of your gas hob as well. They're the two areas that you use gas in your home, potentially. Not paying for maintenance. One of the big things about heat pumps is they don't really break down, and not a lot goes wrong with them. So I was having a chat with Clarion Housing and Moat Housing with Merton Council recently, because they're the two big providers within the borough of Merton. And I asked the guy from Clarion, who have 125,000 properties across the country, so by far the largest housing association, and they have about 1,200 of those have heat pumps on them. And I said, well, what's your difference between O&M costs of running a gas boiler against O&M costs of running a heat pump? And he said, well, it's infinitely better. I said, why infinitely? He said, well, we don't have a policy for our heat pumps because we've installed them for 3 or 4 years now, nothing's gone wrong, so we don't have a policy. And although that seems a little bit extreme, it is illustrative that if a big housing association like that considers heat pumps, install them, worry about them, maybe 10 years down the line, then that's something that homeowners can probably think about as well. So I know, for instance, if you look at the British Gas offer tariff to look after your boiler, we have one at the moment, and I think it costs £12–15 per month, but they can be up to £30 a month depending on the standard of service you have. Well, that's £270 a year times 7 years plus inflation. That's another £2,000 you're looking at that you can claw back into these economics. So you kind of need to build a case for the resident here, saying, look, you're avoiding this cost, you're avoiding this cost. Yeah. If you become a bigger consumer of electricity, you might get a better rate as well. So rather than consuming, say, 3,500 kilowatts just on its own for your lights and your TVs and things, suddenly if you're now consuming, say, another 5,000, you're suddenly almost a commercial-sized operator. You might get a better tariff from somebody because they think, oh, I want that 8,500 kilowatt client. They're good clients for us. Finally, the other bit is looking at things like time of use tariffs. So this whole demand shifting thing. So we've done a bit of research where we think with a 250 litre tank, you can shift maybe 3 hours of heat. If you can do that, then you can avoid the peak periods and therefore have a cheaper tariff. And again, that feeds into the economics of it being that much cheaper to run the gas over a long-term period.
Okay, thank you. And the next question, we probably would have some similarities in your response here, but this is strictly about communal systems. A question from Asaru. How do you get everyone to agree to use the system? What if some householders don't buy in?
I think it's going to be hard. I mean, it depends on pipe work. So if you've got the instance we're looking at in Islington, it's one big communal system already. I think there's a starting point. That makes it easier because they've already got buy-in to a communal system. If not, it's more difficult. It's more difficult to leave people out depending on the plumbing. So a lot of it will depend on pipe work, really, to answer that. Guy, have you got a response to that might be a bit more technical than me?
It very much depends upon the building itself. You really can't look at buildings as a whole. Every single building is going to have to be looked at. We've always start from the point of comfort of each individual unit within the building, or the building as a whole, if it's somewhere like the Devas Club, and work back from that. There's no one rule, I'm afraid.
Thanks. And then I think in terms of the buy-in, how do you increase the buy-in? I think you've got to show the economics of it. You've really got to show things like we've already just discussed. Lower running costs, lower O&M costs, less likely to break down. So, as soon as it gets cold, boilers break down. That's not going to happen with a heat pump. So you've got that comfort of knowing that these things just run and run. And think of a heat pump, if you're not really that au fait with heat pumps, as the reverse of your fridge. If you fill the back of your fridge, it's really, really hot, and the inside is really cold. Heat pump's just doing the same thing, but in reverse, really. And when was the last time your fridge broke down? Those things run forever. Heat pumps can really run forever, really. So I think you sell those points, the reliability, the running costs, and just generally the environmental aspect of it. This is the carbon. and local air quality. You know, by getting rid of, say, on a housing estate, getting rid of maybe 100 different gas flues, you're going to have a lot clearer air in your immediate area where your children are playing. So you need to make a big point of that.
Yeah, I guess it depends who you're talking to and choosing your engagement method that works for those groups of people as well. Great. Okay, so we've got a question from Martin Kemp on air source heat pumps in a densely populated area. Is there concern on new developments impacting the airflow and therefore SPF? Are there ways to mitigate this?
I think that's probably one for Guy.
Sorry, the airflow affecting the SPS?
SPF I've got here. Is that an acronym that you know? Maybe I can bring more.
Yeah, performance factor or
Okay.
the COP of the heat pumps.
Yeah.
So I think the question here is about creating microclimates, Guy.
I think at the kind of installation levels we're currently talking about and might be talking about for the next 3 or 4 years, I'd be staggered if that's going to be an issue. It clearly needs to be something that is looked at. There were some questions on the chat earlier regarding the impact on the grid, which I guess falls into the same sort of category. Currently, when you're looking at the grid, the sort of things that you need to look at are startup of heat pumps. There's a bit of a spike, particularly with single-phase heat pumps unbalancing the system, and that attention needs to be paid to that, particularly when you have large numbers of heat pumps operating in blocks. But in terms of the ongoing general running, we're a long way from the sort of impacts which are going to be upsetting the grid. The grid operators generally believe that if we're looking at a reasonably long transition, like 5, 6, 7, 8 years to say 20 or 30% heat pump impact in domestic heating, they will cope with that. Needless to say, there are going to be localized issues, probably more country than London. But I think in the short term, we're a long way from those kind of issues. And I think the same thing would apply to any small disturbances in the local climate. The benefit to particulate emissions from reducing boilers, gas boilers in particular, will have a way greater impact in the other direction.
I'd just say on sort of the microclimates bit, we know, for instance, like people would love to put their heat pumps down in the basement, you know, by the basement flat of a sort of Georgian townhouse, for instance. Outside, you know, out of mind, but they do create microclimates. You know, the cool air just sits low, and therefore you do lose efficiency. So there is a lot of consideration given to where heat pumps are placed and how you stack them. You know, there's been examples previously of people cascading heat pumps where the cold feed is feeding into the hot feeder one behind it, and lo and behold, you know, the efficiency of these heat pumps is tragic. So, but people have learned from that. So I think spacing heat pumps out a little bit, making sure there are places where there's a constant airflow are going to be key. So you don't want them down a small alleyway where there's not a lot of airflow. So you can kind of address them by placement as much as anything else, and spacing of those heat pumps.
Okay, great, thank you. And thank you, Guy, for covering the network constraints as well. Just on the network constraints, so you said that it's not going to be an issue for you, and I guess there's one question that's just asking, where there are grid connection restrictions, has the viability of including community scale renewable energy and battery storage been looked at to be able to roll out these solutions in these restricted areas? Do you know of any other projects that have looked into this?
I've had conversations with Western Power, and funnily enough, I got one this afternoon with UKPN about these kind of issues. And part of our presentation here was about demand shifting. So having a buffer tank. Now we're doing this economically. Now, if we're incentivized to not turn our heat pumps on between, say, 4 and 5 by the grid, great. If that means that they don't have to spend lots more money on making the grid more resilient, then there's your solution. So I think a lot can be done on that. We were talking about with a guy called Roger Hay from Western Power that many people might know on the call, depending how the location. And he was really keen to run a resilience test of maybe 500 homes with heat pumps with this buffer tank solution. And it doesn't matter whether it's a buffer tank or whether it's a battery storage. You know, as long as you can kind of shift that demand away from peak periods, can you stop that massive ramp up of heat pumps all at more or less the same time? And I think you can. You know, I think there are ways of doing that without destabilizing the grid. So I don't know where they got to on running those trials down in the southwest, and UKPN. I'll find out later today, and I'll happily put it on social media and on chats or whatever for people to find out, you know, how UKPN are thinking about this. But clearly, as Guy has said, you know, it's not such an issue in London because there's just such a huge amount of sink of energy immediately around you at any given time anyway. This will typically be a more, you know, country issue, rural issue than it will be a urban issue.
Yes, certainly, yes. Okay, thank you. I've got a question from Cara around Octopus time of use tariffs. I've heard that Octopus time of use tariffs is very expensive outside of the cheapest time of use, which may end up costing the homeowner more overall. Has this been looked at in real-time use?
Yeah, I had a look at this, and I didn't think that was the case. I think it was around about 15, 16p if you kind of just ignored the time of use element of it and just used 24 hours a day of tariff. So no, I don't think it is. I would argue that at the current rates, they don't want too many people on it, is my guess. It really is a trial to see how it can work and how they can kind of encourage people out. But you got to think, if you think back to sort of things like triad payments, and triad is a commercial thing, but it's the 3 worst half hours of the year for commercial tariffs. And there were certain rules. There had to be, you know, 10 days apart, and they had to be between 4 and 7:30 at night, and they had to be between November and February. But if you avoided those, you could avoid 12.5% of your bills. So the very worst case scenario points have a huge, huge impact on what people pay. So, you know, you can have tariffs going to £30,000 per megawatt hour for that worst half hour of the year, when they're normally £50. So, you know, avoiding 4 till 7 consistently through February can have a huge impact in what you're avoiding, therefore what Octopus can charge you. So the studies we're looking at, you know, clearly you need to be able to avoid the rest of your energy consumption as well. So your lights and TV and your oven and all your other electrical things. But our feeling is the people who are on that tariff have probably already got PV and battery storage, and that's why they're on that tariff. So we're just an addition to that, really. Typically, I think will be the case.
Okay, thank you. I've got a question from Peter. Have you investigated combining air source heat pumps with, and I'm going to try, I think it's mechanical ventilation heat recovery, MVHR, something like that, for properties that have to be ventilated from rear due to street NOx levels, so nitrous oxide levels?
No, we haven't, and I think there's probably also a case there for that with homes that are damp. You know, so if you're looking at blocks of flats where, I don't know, they've got cavity wall, but they might have dampness from through each floor. You know, where you've got concrete slab floors, you create a lot of damp there. So those places need to be vented. So I think there's going to be a good market for that. I just think at the moment it's too technical for us to be involved as one of our early projects. But I think it's a great point, and I think it's something that Guy, I'm sure, would love to be involved in as the technician in the team. But Guy?
It's not something that we've looked at all. It sounds interesting, and certainly there are lots in London, lots of buildings to which it would apply, lots of substandard buildings. One thing that has come up quite often, and is a project that probably needs doing ahead of installing heat pumps, is looking at the kind of lowest temperatures you can get on existing heating systems in buildings, and that's an area that we've looked at a little bit. In terms of air quality and dampness in buildings, no, we've done nothing on that front.
Well, and just one point I touched on earlier, which was looking at some of the ground source installers who are trying to reduce the footprint. So they're going down about 250 meters, they're using steel pipes, so their efficiency of taking heat out the ground is better, and all those kind of things. One of those groups, a company called, I think it's Black Mountain Development, they're looking at combining heat recovery and storing heat in the ground. So if you took, say, one example we're thinking about might be a potential with them is gyms, health centres, where there's a lot of wastewater from showers. There's a lot of heat that's taken out of the gym rooms, where all the equipment is, those kind of things, and recycling that heat. And what they're looking at a system where they can actually store some of that heat into the ground and then use it later. So that's kind of halfway to what the question was from, was it Martin? So.
Thank you very much. Got a question from Dave Faulkner on permitted development. Could Toby please clarify the comment about heat pumps being permitted development and being within 1 meter of the building boundary wall?
Yeah, our understanding in London, at least, is that it is permitted development, but you do have to be a metre away. The only exceptions there are if you're in a conservation area or if you're a listed building, and then you will need additional permissions. So, and that's a problem in London. I think half of all conservation areas across the country are in London. So there's around about 500,000 homes across London that are in conservation areas. And it's very similar to solar PV. So my feeling is the solution, we haven't faced this yet, but my feeling is the solution will be the same. If the solar PV is on the back of the building, can't be seen by the road, that's fine. I guess it will be the same heat pump. So you won't be able to have your heat pump out the front of the house in a conservation area. If there's a listed building, it's a whole lot bigger argument to have. And you've really got to build a case of why you would need a heat pump rather than something else. But yeah, I hope that answers a bit more than I have already, but it's probably not everything he was looking for.
Thank you. Got a question from Peter Hirschfeld. What about the cost of servicing air source heat pumps to vulnerable customers in order not to invalidate the warranty on the machine? That cost needs to be included somewhere. Any thoughts on this? Yeah,
I mean, it's funny, isn't it? This, I mean, if you're talking, my example of the largest housing association in the UK doesn't have a policy around this. It's kind of interesting, but essentially what you would pay for is, in this day and age, is remote monitoring, really. All these units have comms units attached, and then you can argue, well, how do you connect the comms and all those things? So essentially what you're paying for is possibly a GSM card for a year, which is £9 or something. Or if they've got internet, that's great. You will pick up the messaging on the heat pump from there. And then you might want to pay for some security. So Kiba would be the sort of European example of, and they cost around about £40 a year to have a Kiba security key on that heat pump. So people, because there has been cases of people hacking into someone's home via their heat pump comm system. So you would then have to think about how you would build that cost into the system. And we haven't done that yet, but because we're looking at these communal buildings, is something that we may have to consider or may not. But when you talk to the installers and you talk to the manufacturers, they pretty much say, look, we're comfortable. And remember the warranties on these things. So someone like Nebi, for instance, will offer you a 7-year warranty, parts and labour. So its first 7 years, you really don't have to worry too much about it. They're that confident that their heat pumps won't break down. So it's just finding that balance, and it will come down to the economics. If you can add £50 a year of O&M costs in there to monitor this stuff, great, build it in. If you can't, are you prepared to take that chance on the heat pump running? It's kind of crunching numbers time, really, I think, is how you make those decisions.
Yeah, Okay, thank you. Question from Tracy, which I think is particularly interesting because of being in London, but have you thought about using heat sources which are created as a result from sewage works? And I know, Tracy, I don't know if you saw there was a response from Penny to get in contact with Leapfrog Launchpad on this because it's quite a specialist topic. But I thought maybe, Toby, if you had any thoughts on this or knew anything of this happening.
Yeah, we're back to Black Mountain developments actually, and that's something that they are looking at, taking heat out. Where can you recover heat from? I'd also say look at Islington Council. They ran a really interesting project about 2 years ago, I think now, where they took heat from, I think it was the Northern Line of, the London Underground, and fed it into a heat pump that then fed a block of flats above that. So I think there's an enormous amount to be done there, because I don't know how many people have been on London Underground, but it's pretty hot pretty much all year round. So there is definitely an option there. So I think it's interesting, and I think it's just finding the right technologies that partner with that. And someone like Black Mountain Developments clearly have that technology to be able to take that heat and even store it. Take the heat from the sewage works, potentially store it in the ground, then release it later on when they need it. So it's something that we would definitely love to look at and work with a council on. I think where we are, we're all above ground at the moment on the tube network in Wandsworth and Merton, so that's probably not an option for us, but working with Islington on other projects might be interesting.
Okay, great, thank you. A question from Juan. It would be great if you could comment on how are you performing the CO2 reductions calculations? Is it using actual grid emission levels from the national grid or just based on some general estimation projection? And if it is estimated, are you considering to verify if those projections are being met after the systems are in use?
Yeah, it's a good question, Juan. I typically, at the moment, when I'm doing sort of base modelling on that, I'm looking at things like energy saving trust, carbon trust, getting numbers from them. I have looked at live data, and the reason we've looked at live data is this ability to shift demand. So if we shift from 4 till 7, where the carbon concentration might be 300 grams per kilowatt hour, to overnight where we might have a really windy evening and it's 60 odd grams, that you can actually have exactly the same amount of consumption but reduce your emissions by 80%. So it's an area we're looking at and we're researching at the moment, and it's fascinating. You go to all those kind of sites, like energy saving trust, carbon trust, everyone has different numbers. Everyone has a different number of what gas is at the moment. And I can understand why the grid is different, because we're constantly decarbonising the grid. One area that came up, I wrote a blog piece. If you look at my LinkedIn page, I wrote a blog piece on how far behind BRE are on heat pumps and how they treat heat pumps under RDSAP and therefore your EPC. And that touched on a few pieces really. One was, if it wasn't part of their product list, you only got 12 points for a heat pump, where you're getting 43 points for a condensing boiler. Ludicrous. They use 3-year rolling averages for oil. Therefore, in this particular example we had, oil was cheaper to run than the heat pump, which it clearly wasn't. They also use 250% efficiency for their heat pumps, when MCS won't accredit anything for less than 290%. And then the final part was they were still using, until very recently, like the beginning of this year, they were still using 505 grams of carbon for the grid intensity. And I said, well, how can you be using that? It's just a ludicrous number. And it was 4 years old. So that number's now down to 200, but obviously it's constantly falling. So you could use live data for the last sort of year of what's been produced in your area. There's clearly a number of websites that track this stuff. But yeah, it's a great question, Juan. And I would love to, if Juan wants to get in touch, I'd love to have a chat with him about what he's looking at on that and whether there's work we can do together. But the bit I find most frustrating is, what's the number for gas? It can't be different. It's just got to be what the number is. And you see different numbers by different people. So I try to use something I think most people will accept: carbon trust, energy savings trust, just as a baseline. And then you're also debating one other area is how efficient are boilers. So, a typical boiler is 85% efficient. New condensing boilers are meant to be 90-something% efficient, but they're only 90-something% efficient if you run them around about 60 degrees. We're all running them like we've always run all our other boilers at 70-80 degrees. Then they're back to 80% efficient. So, you know, a lot of it is how are you running your kit as well. It's key. And when you run your kit with heat pumps is really key, because the curve of carbon throughout the day is very, very different.
Okay, thank you. Yeah, Juan, get in touch if you want to discuss this further. So we're coming up to time now. I'm just going to probably cover 2 more questions. If there weren't any that were covered, do get in touch with us afterwards. But question from Penny: speaking as someone who is noise sensitive, have you looked at the acceptability of noise applications, as in, for example, speaking with someone from the UK Noise Association?
We haven't, but as you've seen from the presentation, it's something we're really thinking about. And if you look at that sort of top end of the scales, like some people have been recommending a new Valent boiler, Valent heat pump, as a really interesting hybrid solution. But when I looked at it yesterday, it's got 66 decibel noise level. So what we need to do is find heat pumps that are quieter. So Oshner is a great example. They're expensive heat pumps. You know, they're a split system, which means the fans are outside, the refrigerant is inside. But you know, they're 29%. So that is whisper quiet. You know, you're not going to have an issue with those. But there are heat pumps somewhere between those 2 scales, where you know maybe at 30 or 40, between 30 and 40, where you're below London noise level. That we're thinking that will be okay. The other thing is noise levels drop immediately you get away from them. So that number that you see as the headline, that 66, is if you're standing next to it. If you go 2 meters away, I've got the NEBI numbers somewhere. I will try and put them on Twitter or something later, so you can follow it. But if the NEBI number might be 50, but if you go 2 meters away from that, it drops to 35. If you're 6 meters away from it, you're down at 20 something. So then you're below whisper. So positioning of the heat pumps is going to be really, really important, as well as the type of heat pump you're using. We're also thinking about what other things can be added to the heat pumps to kind of dampen the noise down. So could you put on, like we're working with an insulating product at the moment, it's a spray-on resin. It insulates home, but it would obviously also dampen sounds in the same way. So could you put that on and reduce the sound? So things it's a really big consideration for us, particularly in London where there's not space and we're all on top of each other. And if you thought you could have a whole street of heat pumps all humming away at 55 decibels, it's going to be pretty unpleasant. So we do need to find solutions.
Yeah, and definitely if you were to take that in a rural area where things tend to be more quiet as a background noise, that would probably show up a lot more.
Yeah, but then you can argue in a rural background, you know, putting it in a house where no one's within 7 or 8 meters of them, that noise has died down before it gets to the next person anyway. And you can put it into the garden, around the back, away from everybody and away from themselves even. It's easy. Whereas when we're on terraced housing, back to back, gardens next to each other, you know, it's tougher.
Yeah, definitely. Okay, so I'm going to probably end that now. I know that there's a couple questions that weren't covered, but just to kind of wrap things up, because I can see that people are starting to leave. But thank you so much for everyone's questions. If your question wasn't covered, then please do get in touch with us or with Toby afterwards and we can have a chat. But thank you. And Rachel, I'll pass back to you to close off.
Thank you, Megan. And yeah, thank you, Toby, and thank you, Guy and Amy, who've been answering the questions in that session. Yeah, great session, lots of information. And yes, we will be sharing a recording of this webinar, as we always do, on our Next Generation website. And recordings of all the previous Innovation Lab webinars can be found there too. So please head over to the website if you'd like to see the recording, or if you'd like to share it with any colleagues that couldn't come along. And the next Innovation Lab will be hosted by Low Carbon Hub, and they're going to be talking about their Project Leo. So please sign up for that if you'd like to. I've put the link in the chat box and I'll circulate it again after this webinar. Yep, and that's on the 23rd of September, so please come along if you can. But yep, thank you very much, Toby. That was fantastic, and thank you everyone for coming along.
Thanks for the opportunity. Thanks for listening, everybody.
Thank you, everybody.
Thanks.
Bye.
Bye.